Back in 2017, ESO announced that they would be releasing the most detailed image of a black hole ever to be seen. This image would be constructed of 27 petabytes of data. That's like 27 million gigabytes of data. So it's no wonder it's taken them so long to process. After 2 years, next week on Wednesday, the 10th of April, ESO are going to release this image. And in this video, I'm going to break down exactly what that means. A black hole is a massive thing squished into a tiny space. The gravity of a black hole is so strong that nothing, not even the fastest thing we know of, light, can escape it. And that's why we can't see it. Black holes are predicted by Einstein's theory of general relativity. But observations of stars close to the center of our galaxy, the Milky Way, show that they're orbiting around something very, very massive squished into a tiny little space. A black hole. We know that the object is very massive because the stars are orbiting around at very, very high speeds. They should be flying off all over the place, but they're not. They're held together by the strength of the gravity of the black hole. The black hole at the center of our galaxy and at the center of most galaxies we know of are not any ordinary black holes. They are supermassive black holes. That means they have masses, millions if not billions times the mass of our sun. Black holes don't emit any light, so it's very difficult for us to see it. However, if a black hole is active, that is to say it's feeding, then it will have a disk of material that is being gobbled up by the black hole. This is known as accretion. And as this material is being accreted, it gets heated up to very, very high temperatures, and this shines brightly in the X-rays. Also, a black hole might have some jets of particles emitted from the poles at very high speeds, speeds approaching the speed of light, and this we can see in radio waves. The Event Horizon Telescope is a global network of radio dishes that work together in unison to observe objects like black holes. The combined efforts of these radio dishes act like a single radio dish the size of the entire Earth, and this is what will allow us to make high-resolution imaging of the black hole at the center of our galaxy. The event horizon marks the edge of a black hole. It's the point where any material falling in will never be able to come back out. The shape and the size of the event horizon is well predicted by Einstein's theory of general relativity. And that means by looking at the event horizon of a black hole, we can test if Einstein's calculations are really correct. Detailed theoretical calculations of what a black hole might look like were made for the Hollywood movie Interstellar and then visualized with simulations. And I think we can expect to see something similar. A black silhouette against a glow of radiation. And if we're lucky, we might even see some gravitational lensing effects. Our black hole, however, is not particularly active. That means it's not feeding right now. So it's kind of strange that we'll see any radio emission at all. It could mean that the disk is emitting radio emission, which would be very strange, or that we are wrong and our black hole is very active, but the jet is pointed directly at us. I guess we'll find out on Wednesday. I hope to see you then.